The greatest integer function is a piecewise defined function most commonly referred to as a step function, probably because it resembles steps. This function takes a real number x and outputs the greatest integer less than or equal to x. Let's graph this function, the greatest integer of x. To graph this function, I've given you a table of values here where we've already input some values for x. Let's evaluate these values of x so that we can get our output and see what this graph would look like. Let's begin by plugging in negative 1.5. So if we remove the x and replace it with negative 1.5, what we want to know is what is the greatest integer that is less than or equal to negative 1.5. Well, let's take a look at our graph because our graph can help us to be able to determine what that value is. So negative 1.5, you know, would be on the negative side between negative 2 and negative 1. So we want to know what is the greatest integer that is less than that decimal of negative 1.5. And what is it? Yes, you got it. That would be negative 2. And how about negative 1.25? It's going to be the same because that would just be a little bit closer to negative 1. However, we want the integer that is less than that value of negative 1.25. So again, that would be a negative 2. And that's going to be the case all the way till you get to the next integer, and that's the case of negative 1. So we want to know what is the greatest integer less than or equal to. So remember, if it's an integer, it would be equal to, so it would be negative 1. Okay? Because recall that the greatest integer function is only going to spit out or give an output of an integer, never a decimal. So if you have a decimal, all you're looking at is what is the decimal that is smaller than that number. What is the nearest decimal? So on greatest integer function, you're pretty much, if it's a decimal, you're going to be rounding down, which means you're going to move to the left to identify that number. So in the case of negative 1.5, when we round down and move to the left of that number, that's why it was negative 2. So now with the number of negative 0.75, that's not quite negative 1. It's right between 0 and negative 1. But because it's a decimal, we're going to round down, which we're going to move to the left to find a integer that's less than, and that integer would be negative 1. And that's going to be the case also for negative 0.5, and it's going to continue that way all the way until you get to your next whole integer, and that would be 0. And so for your integers, the number that is going to be equal to that is 0. Okay, it is always less than if it's a decimal. If it's a integer, then it's going to be equal to, it's going to be the same as that. Now we're at 0.25, and that would be on the positive side to the right. That's between 0 and 1. However, we want the integer that is less than that value, so we're going to move to the left, and that would be 0. Same thing for a half. That's still 0. It's going to be that way all the way until you get to your next whole value, which is your integer of 1. 1.25, we're here, and to find the integer that is less than that. So move to the left of that, and that would be 1. It's going to continue that way for 1.5, 1.75, all the way until you get to the next integer, in this case, which would be 2. So notice that the function increases to the next greatest integer when the x value becomes an integer. So if we were to plot all of those points, this is what our graph would look like, and notice it does resembles steps or stairs. This graph is a little different from most graphs you are used to seeing. It is not continuous, meaning you cannot draw this function without lifting up your pencil. It is also constant for a little bit, and then it jumps up to the next integer, and then it is constant, then it jumps up, and it sort of kind of repeats that pattern. So what is the domain of this function? So the domain, then, we want to know how far this graph will extend to the left and to the right. And actually this graph, the graph of a greatest integer function, is one which has a domain from negative infinity to positive infinity. Okay, you can put in any real numbers and get an output of an integer. The range, how far it extends both up and down. Well, notice that with your range in between, you have places where it jumps, and basically that is those places where it is not an integer. It's those numbers that are in between, so it jumps up to an integer, which means that our range would only include just our integers. So all real numbers that include integers. Discontinuous, this particular graph, as we stated before, it is not continuous. You cannot draw it without lifting up your pencil. So it's discontinuous over its entire domain. Now let's look for places where it's constant, where it kind of remains the same. So as we can see here, now of course the graph goes from negative infinity to positive infinity. Let's take a look at just what we have here on the screen, just this section of the graph. I can see that it's continuous from -3 to -2, and then it jumps up and continues from -2 to -1, and so forth. So it is again a function that has constants, and then it jumps up to its integers, and it just sort of repeats that process throughout its domain, and that's the greatest integer function.